There is a powerful force hiding underground where tectonic plates meet, and one forces another under it. This happens in the Pacific and Indian Oceans. Strain builds over centuries. The tension is unbearable until the megathrust awakens. The Earth shakes with a magnitude that can exceed 9 points, more powerful than any other earthquake. When the seafloor suddenly gets pushed up fast, it sends a huge ripple across the water, and a tsunami of huge force is out. These waves are called teletsunamis, and they cross entire ocean basins, ready to take over coastlines thousands of miles away. The thrust fault stretches over 600 miles. The Earth is not just shaking, it feels like it's tearing apart. This is the power of a megathrust earthquake. Those caught in its path will have to fight for their lives. Japanese authorities recently had to issue their first ever megaquake advisory. It happened because of a strong tremor on the edge of the Nankai Trough ocean floor zone. In the end, most of the warnings were lifted, and there wasn't much damage from the 7.1 magnitude earthquake. Parts of southwestern Japan started to shake, and the superfast trains in Japan slowed down to stay safe, which made travel slower for everyone. But everyone is staying alert as they know about the risk of a megathrust earthquake that could happen within the next few decades in the Nankai Trough. The tectonic plate under the Philippine Sea is slowly sliding underneath the land where Japan is, moving just a few inches every year. The last big earthquakes from this area happened in 1944 and 1946, both with a magnitude of 8.1. These quakes have caused a lot of destruction in the country. The next megathrust earthquake in the region, if it does happen, could be between a magnitude 8 and 9. Scientists still can't agree on how likely this mega earthquake is to happen, but it could be up to 80% certainty. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia Subduction Zone, and it stretches from northern California to northern Vancouver Island in Canada. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happens every 500 years on average. But for a long time now, Cascadia has been quiet, and it worries scientists. They think this might be because the area is locked, meaning the tectonic plates are stuck together and building up a lot of pressure. Eventually, the part of the seafloor could suddenly break and move by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. The ground on some inland hills could turn into something like quicksand. This would cause the hillsides to slide and crumble, taking down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse, including about 100 hospitals and 2,000 schools. People in Washington state might have to take care of themselves without help for 2 weeks, finding food, water, and shelter on their own. Scientists are studying slow slip events, where the tectonic plates move very slowly over weeks or months, releasing some energy but not enough to stop a big one. Every time the magnitude of an earthquake goes up by just one number, the energy it releases is 40 times bigger. So we'd need about 1 million small earthquakes every day for 500 years straight to release the same energy as one huge magnitude 9 earthquake. But these small earthquakes might be clues that a bigger earthquake is coming. To better monitor the Cascadia Fault, experts are mapping the fault more accurately and adding better monitoring tools offshore. Scientists receive over $10 million to install seismic sensors and seafloor pressure gauges on a fiber optic cable off the coast of Oregon. The goal is to be ready to warn people and potentially save lives when a big earthquake strikes. A sharp megathrust earthquake happened in this part of the world in 1964. It went down in history as the Great Alaska Earthquake and had a magnitude of 9.2. It lasted for more than 4 minutes, making it the most powerful earthquake in the history of the U.S. and North America. The ground shook so hard that it caused huge cracks and landslides. In Anchorage, many houses, buildings, and roads were destroyed because they weren't built to handle such a big earthquake. In some places, the land was permanently changed. For example, the coastline near Kodiak and Hinchinbrook Island was lifted by 30 feet. In other areas, like Gerwood and Portage, the ground sank by 8 feet. They had to rebuild roads higher so they wouldn't be flooded by the tide. A huge 27-foot tsunami wiped out the entire village of Chiniga. Many coastal towns were heavily damaged, not just by the earthquake, but also by tsunamis and the fires that followed. After the main earthquake, there were thousands of smaller aftershocks for months. A moderate earthquake of magnitude 4.4 shook Los Angeles in August 2024. Once it was over, the LA Fire Department checked around the city and didn't find any major damage or anyone hurt. In the nearby city of Pasadena, which is close to the earthquake's epicenter, a water pipe burst inside City Hall and everyone had to leave the building. Thankfully, there was no danger of a tsunami. The best we can do to avoid panic in such situations is to be prepared. Japan is one of the places on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. Around 1,500 of these earthquakes each year are noticeable. Because of this, the people in Japan have learned to live with earthquakes. The 1950 law set a rule that buildings should be able to handle earthquakes up to a magnitude 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is to not collapse and save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. Another technique is placing special pads made from materials like rubber at the base of a building. Some buildings are even built on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot, moving up to 5 feet. To stop it from getting damaged, engineers can add something called dampers every second floor all the way to the top. These dampers are like giant bicycle pumps, but instead of air, they're filled with liquid. When the building shakes, the dampers push against the liquid inside them. Even though the liquid doesn't squish very much, it can still absorb some of the shaking. When they're building tall skyscrapers, engineers try to make the structure as simple and balanced as possible. This means having each floor the same height and placing the support columns evenly. But sometimes, architects who design skyscrapers don't want to make these compromises because they have creative ideas for how the building should look. Then they have to find compromise solutions. For example, Tokyo's Skytree Tower, one of the tallest buildings in the world, is designed in a futuristic style but also includes special features to protect it from earthquakes. It has a central pillar, like in traditional Japanese pagodas, and seismic dampers that help absorb the energy from an earthquake, keeping the building safe.
For hundreds of years, people in the US have reported hearing strange, loud booms. These mysterious sounds are called skyquakes. And yep, it's a real thing. If you've ever heard a loud, distant booming noise that definitely wasn't a thunderstorm or a car engine backfire, congrats, it looks like you've experienced a skyquake yourself. People report them all around the globe, from the US to India and Japan. They go under different names, and we still don't know why exactly they happen. Sometimes these booms come together with earthquakes. People heard them during the New Madrid earthquakes in the early 19th century and up until January 2020. Those who've experienced them describe skyquakes as a rushing or rolling noise. Famous American writer James Fenimore Cooper described it more poetically as the lake speaking to the surrounding hills, which send back the echoes of its voice in accurate reply. Sometimes these mysterious booms happen in cold weather instead of during earthquakes. One of the skyquake hotspots is near Lake Seneca in New York. They call them the Seneca Guns. The booms can be so loud that they shake windows and doors. Back in August 1886, after an earthquake in Charleston, people heard these noises for several weeks, happening at the same time as many aftershocks from the earthquake. In 2020, scientists from the University of North Carolina looked at old news pieces, especially from North Carolina, where people have often reported these sounds. They hoped to match the noises with earthquakes data, but they didn't find any link between the sounds and earthquakes. One of the researchers said they believe the noises are happening in the air, not underground. The team looked at infrasounds, which are low-frequency noises that humans can't hear. They found signals lasting 1 to 10 seconds that matched the times when people reported hearing the booms, but nothing is certain here. Some people think that solar flares, underwater tsunamis, or caves collapsing under the sea cause skyquakes. Others believe the sounds come from planes making loud sonic booms. But that doesn't explain old records of skyquakes from the past before planes were even invented. Some scientists think a type of meteor called a bolide causes these booms. These meteors blow up when they hit Earth's atmosphere. If this happened above thick clouds, the sound would get louder and travel far, but we wouldn't find anything on the ground. Another idea is that gas might be escaping from the bottom of deep lakes, like Lake Seneca. If you think skyquakes are bizarre, let me introduce you to fog bows. They also go under the name of white rainbows, ghost rainbows, or cloud bows. They form in a similar way to regular colorful rainbows, but are much wider. Rainbows happen when there are big raindrops in the sky, and you can always spot them on the opposite side of where the sun is shining. Fog bows are made by tiny droplets in fog, or clouds, instead of big raindrops, and they also appear opposite the sun. If you want to see a fog bow, you need to look for it in a thin fog when the sun is bright. You might catch one when the sun starts to shine through the fog, or if you're near the ocean where fog often forms. Because the water droplets in fog are so tiny, fog bows don't have bright colors like rainbows. They might even look all white, or just have faint colors. Some fog bows are hard to see at first because they blend into the mist, but once you spot them, they're easy to recognize. The next rare weather phenomenon you gotta watch out for is thundersnow. You guessed it right, it's a special type of thunderstorm that happens during a snowstorm. Unlike regular thunderstorms that often strike in the spring and summer, thundersnow is much rarer because it happens in the strongest winter storms, like big blizzards, and at the same time needs warm air, which isn't a frequent combo. So, for thundersnow to happen, there needs to be moisture in the air, some instability, and something to lift the air, like rising winds. Just like in normal thunderstorms, lightning can appear when you hear thunder. Thundersnow lightning usually goes from cloud to cloud instead of hitting the ground, and the thunder sounds different too, more like a low rumble instead of a loud boom, because the snow muffles the sound. You aren't so likely to get struck by it, but it's still important to stay inside when you hear thunder to stay safe. Northern Lights fans, this one is for you. Scientists noticed a new kind of glow in the sky that looked like a purple streak. They nicknamed it Steve as a joke, but later gave it a more scientific name: Strong Thermal Emission Velocity Enhancement, Steve for short. Steve is actually a fast-moving stream of super hot gas that always moves west and only shows up before midnight. They wondered if something like Steve could happen after midnight, but moving in the opposite direction. And now, scientists think they found the anti-Steve by looking at data from a research station in Norway. In December 2021, they took a picture of a bright purple streak stretching for 620 miles in the sky, and it only appeared after midnight. Satellites from the European Space Agency also measured the conditions in this part of the sky and found that the ions were moving eastward. Steve's late-night twin hasn't been officially named yet, but it would be cool if it was called SAM, which is short for Steve After Midnight. If you've ever seen snow on a sunny day when falling from the sky without a single cloud, it must have been diamond dust. It's a special kind of weather with millions of tiny ice crystals forming close to the ground. These ice crystals float slowly in the air, kind of like how dust floats in your house. When sunlight hits these crystals, they sparkle like diamonds. Unlike regular snow, diamond dust can fall from a cloudless sky, which is why they sometimes call it clear sky precipitation. It happens because of temperature inversion. Normally, it gets colder as you go higher up from the ground. But in a temperature inversion, the cold air stays near the ground, and warmer air sits above it. The warm air has more water vapor, and when it mixes with cold air near the ground, it turns directly into ice crystals, and diamond dust is born. For this to happen, the air near the ground has to be really, really cold, way below freezing temperature. Diamond dust can fall for days, but it's so light that it usually doesn't pile up on the ground like regular snow. A fall streak hole, also known as a hole punch cloud, is next on our list. This big circular or oval-shaped gap sometimes appears in certain clouds. These types of clouds float high up in the sky and are often made of tiny water droplets that are colder than freezing, but they haven't frozen yet. These special water droplets are called supercooled, and they need a reason to freeze. Ice crystals give them that reason. When a plane flies through the cloud, it can bring those ice crystals into the cloud. Once the ice crystals are there, the supercooled water droplets freeze quickly, get bigger, and start to fall from the ground. This creates a hole in the cloud, and as more nearby droplets freeze, the hole gets bigger and spreads outward. Any tornado is scary, but a fire tornado takes the horror to a new level. These bad boys are spinning towers of flame and ash that form when there's extreme heat, strong winds, and uneven ground. The intense heat from the fire causes hot air to rise quickly. Cooler air from the sides rushes in to replace it and creates strong winds. When winds from different directions meet, it makes the fire spin like a tornado. It gets stronger and can even create its own weather. It pulls in flames, ash, dirt, and anything in its path. The winds can reach speeds of over 140 miles per hour, and these fire tornadoes can last for more than 20 minutes.
So hey, take a look. This is our planet's crust, its outermost and thinnest layer. And here's the mantle. It's way thicker. And this is the core. Wait, what's happening here? Uh-oh, the core is leaking right into the mantle. Quickly, we gotta stop the leak. What do you mean it's been going on for millennia? Earth's core is actually a very intriguing thing overall. Its unique properties, ranging from housing a mysterious metal orb to being nearly as hot as the sun's surface. Well, another one on this list of enigmas, apparently, our planet's core is leaking gas. I can relate. Is it dangerous for us? Is it going to boom if somebody lights a match? Well, not really, all because this gas is a rare isotope called helium-3. Helium-3 is a version of helium with one neutron instead of the usual two. Most of helium-3 in the universe was created around the time of the Big Bang, so it's some pretty ancient stuff. As the solar system formed, this gas became trapped deep within Earth's core. Shielded from space collisions and other cosmic hullabaloo, it remained hidden in the planet's depths for billions of years. Now, we've known for quite some time that occasionally, trace amounts of helium-3 escape to the surface, but no one has known the exact mechanism behind this leakage. Until recently, the breakthrough came with the discovery of exceptionally high ratios of helium-3 and its more common counterpart helium-4 in ancient lava flows on Baffin Island. This island is located in Canada's remote Arctic archipelago. The craziest thing is that these findings have the highest helium-3 ratios ever observed on dry land. The research revealed significant helium-3 levels. It might mean that the volatile elements from the solar nebula, that's the cloud of gas and dust that gave birth to our solar system, have remained in Earth's mantle since the earliest stages of the planet's formation. The discovery was made in lava flows that erupted around 60 million years ago. during the formation of a new seafloor when Greenland and North America split apart. But hey, it was amicable. The research team, led by Forrest Horton from the Woods Hole Oceanographic Institution, used advanced techniques to measure the helium trapped in olivine crystals within the rocks. These crystals formed before the magma erupted, which helped preserve the helium as it rose from deep inside the planet. The scientists found about 10 million helium-3 atoms per gram of olivine. That's a shockingly high concentration for Earth. You see, Earth's core acts as a reservoir for helium-3, storing it since the planet's formation. Over time, small amounts of this gas escape into the mantle through processes like mantle convection. That's when the planet's rocky interior stirs and moves like boiling water. Magma plumes, which appear in the mantle and rise to the surface, carry helium-3 with them. When the magma erupts, most of the helium escapes into the atmosphere. However, some of it gets trapped in crystals within the lava. That's how scientists can later study its origin and movement. Now let's follow the journey of helium-3 in the Baffin Island rocks. It began at least 100 million years ago. Mantle plumes carrying the helium likely took tens of millions of years to reach the surface. It means helium-3 has been leaking from Earth's core for millennia. It also means that our planet most likely formed in a solar nebula containing helium-3 and other noble gases. Baffin Island is an ideal location for studying Earth's deep interior. Its volcanic rocks are remnants of ancient lava flows that erupted when the North Atlantic began to open. The researchers traveled by helicopter to the remote island, which boasts towering cliffs, icebergs, and even polar bears. Local organizations helped the team access the area and ensured their safety during the expedition. The discovery of helium-3 leaking from the core raises new questions about what other elements might be stored deep within Earth. Could it be significant amounts of other light elements, such as carbon and hydrogen? These elements are critical for life and could provide further insights into the planet's habitability and evolution. For instance, the core's lighter-than-expected density might be explained by the presence of these elements. Plus, understanding the movement of helium-3 could also help track the behavior of other gases across the core mantle boundary. But this isn't the only unexpected discovery about Earth's insides. Let's go to Turkey's central Anatolian plateau. There, Earth's crust seems to be slowly dripping into the planet's interior. This process, known as lithospheric dripping, is still shaping the surface geology of the region. Lithospheric dripping occurs when the lower part of Earth's crust, heated to a certain temperature, becomes viscous and begins to flow downward. Imagine a thick liquid like honey or syrup flowing into a bowl. Now you get it. Now, speaking of Earth, it's been happening over a long period of time. And as this material moves downward, it pulls the crust with it, causing the surface to sink. As a result, we see new depressions or basins. Once this gooey material detaches from the crust and sinks further into the mantle, the surface rebounds, causing the ground to rise. This cycle of sinking and rising is what creates the shifting landscape in regions like the Konya Basin in the central Anatolian Plateau. It is the very site where geophysicists observe signs of lithospheric dripping. The research team, led by Julia Anderson from the University of Toronto, first noticed unusual patterns in satellite data, including a circular feature in the region where the ground was sinking. After examining geophysical data beneath the surface, the team identified a seismic anomaly in the upper mantle and discovered a thickened crust beneath the Konya Basin. All this points to the presence of dense material, like a result of lithospheric dripping. The team's model suggests that the Konya Basin is currently in the later stages of this process. While the surrounding central Anatolian Plateau has been uplifting over the past 10 million years, the Konya Basin is sinking at a rate of about an inch per year. While this number might seem small, it is quite significant in a region that is otherwise rising. Earlier studies have shown that the central Anatolian Plateau has risen for around a half-mile over the last 10 million years. It likely happened due to lithospheric dripping. However, the discovery of the Konya Basin reveals that this process is not one-time, but can occur multiple times in different regions. The initial drip that formed the central Anatolian plateau likely caused daughter events, which led to the formation of the Konya Basin. To validate their model, the researchers conducted a cool lab experiment. It simulated the lithospheric drip process. So they took a tank filled with a highly viscous silicone polymer, which acted as a proxy for Earth's lower mantle. They also used a mixture of modeling clay for the upper mantle and ceramic spheres and silica sand to simulate the crust. A dense seed was inserted into the upper mantle layer to initiate the drip. Over the next few days, the researchers observed that the drip descended slowly. Within 10 hours, it began to fall. By 50 hours, a secondary drip had started. The results confirmed that, even without horizontal movement in the crust, the dripping process caused the surface to sink, forming a depression similar to the Konya Basin. This experiment has shown that lithospheric dripping can cause vertical deformations even without horizontal movements. Plus, it has proven that one event can trigger more drips that can change Earth's surface. This discovery helps scientists better understand how Earth's crust behaves over long periods of time and how tectonic processes can affect the landscape. Now, how about a bonus fact? In 1692, Edmund Halley, that guy famous for Halley's Comet, suggested that Earth might be hollow. He imagined layers beneath the crust with two concentric shells and a core about the size of Mercury, all floating in glowing gas. He even went further, speculating that these inner layers could be inhabited. This wild idea inspired Jules Verne's famous novel, Journey to the Center of the Earth. Wow!
On January 26, 1700, one of the biggest earthquakes in history hit off the coast of the United States. It had a magnitude of 9, which puts it in the top 10 most powerful earthquakes ever recorded. This earthquake triggered a huge tsunami and changed the coastline all the way from southern British Columbia down to northern California forever. Back then, the area wasn't very populated, but thanks to some clever research, scientists figured out exactly what happened that day by looking at old geological records, tree rings, and even some history from Japan. On the same day as the earthquake, a massive tsunami also hit Japan's eastern coast. For a long time, no one connected the two, but in the 1980s and 90s, researchers realized the tsunami in Japan had been caused by the earthquake in the Pacific Northwest. They were also able to pinpoint the exact day, January 26, 1700. They even found old trees in coastal Washington that had all perished around the winter of 1700, which matched up perfectly with the timing of the earthquake. The earthquake came from the Cascadia subduction zone, a fault where the Juan de Fuca plate slides under the North American plate. This fault stretches about 700 miles, from northern Vancouver Island in British Columbia to Cape Mendocino in California. The pressure from the moving plates builds up over time, and eventually, another big, devastating earthquake will hit the same region. It's just a matter of time. By looking at the geological records, past tsunami deposits, and signs of land level changes, scientists can figure out how often these huge earthquakes happen. Emergency planners have been preparing for the next big quake, often calling it the big one. Scientists believe earthquakes in the Cascadia subduction zone happen every 200 to 1,000 years. And since the last major one was over 300 years ago, the Pacific Northwest is definitely due for another. When it happens, the earthquake is expected to be as big as the one from 1700. But this time, it'll affect around 15 million people. The devastation will be severe. Buildings will collapse, roads and runways will crack, and bridges will fall. Communication in and out of the area will be cut off. But the worst part? The earthquake will trigger a massive tsunami that might hit parts of the Washington coast in as little as 10 minutes. It's not a matter of if, but when the Cascadia subduction zone will break. When it happens, it will be the worst disaster the U.S. has ever faced. Worse than the Hurricane Katrina or Superstorm Sandy. It'll impact an enormous area stretching from southern British Columbia all the way down through Oregon to northern California. That means millions and millions of people will be affected. Fairchild is considered a backup staging area for handling the aftermath of the earthquake, with Grant County International Airport in Moses Lake being the main one. For those who will survive the initial quake and tsunami, the aftermath could be just as disastrous. Aftershocks will follow, and transportation will be a mess. Roads will be damaged or completely blocked, airports will shut down, and most of the main routes, like Interstate 5, will have bridges destroyed. This means food and water supplies will be cut off, and it will be incredibly difficult for help to get in or for people to escape. Gas pipelines will most likely be damaged too, and restoring them could take anywhere from a few days inland to weeks or even months along the coast. Power outages will be widespread within 100 miles of the coast throughout the entire Pacific Northwest, and water could be out for 3 to 7 months. Even telecommunications will be down for 2 to 3 months across the Pacific Northwest, Alaska, and even parts of East Asia. The good news for eastern Washington is that it will mostly avoid the worst of it, thanks to natural barriers between the west and east sides of the state. The tsunami may hit the Columbia River Gorge, but it will lose energy quickly because of a sandbar under the river. The Cascade Mountains will absorb much of the earthquake's impact, so the east side won't feel it as strongly. And since eastern Washington won't get hit as hard, it'll be up to them to handle the aftermath of the quake. That means helping western Washington, taking in refugees from the areas that got destroyed, and delivering supplies to where they're needed. Scientists have looked at other major 8.0 to 9.0 magnitude earthquakes like the ones in Chile in 1960, Alaska in 1964, and Sumatra in 2004, and Japan in 2011. These kinds of quakes can shake the ground for anywhere between 6 to 10 minutes, and that's a long time for the ground to be shaking. Such quakes are super intense because they happen close to Earth's surface, so it's not just a quick shake, it's a long, strong one that can cause a lot of damage. If the Cascadia earthquake and tsunami were to hit tomorrow, over 13,800 people could lose their lives, and about 107,000 people could be injured. The economic toll in Washington, Oregon, and California could top $70 billion. To put that into perspective, we can compare these numbers with some other major earthquakes. In Chile's 1960 earthquake, about 1,650 people lost their lives. The 1964 Alaska quake resulted in around 140 lives lost. The 2004 Sumatra earthquake and tsunami took the lives of an estimated 280,000 people. And the 2011 Japan earthquake and tsunami caused over 20,000 casualties. Authorities know about the dangers of the Cascadia fault, but even with all the planning, no one can say for sure what will be needed when the big quake hits. Right after the earthquake and tsunami, the areas outside the immediate disaster zone won't be able to help much because roads and airports will be destroyed, and resources will be limited. How can we deal with this kind of disaster and its effects? We don't have all the answers yet. Right now, let's focus on the Cascadia subduction zone. It's a huge fault line that stretches about 620 miles from Vancouver Island to Cape Mendocino in California, sitting about 93 miles off the coast. It's like one tectonic plate is slowly sliding under another. When the plates are close to the surface, about 18 miles deep or less, they get stuck because of friction, kind of like pushing two rocks together. Over time, this creates a lot of pressure. When the pressure finally becomes too much, the plates slip, causing a massive earthquake. This is called a megathrust earthquake, and it can be huge. Below the area where the plates are stuck, there's a zone where the plates move really slowly. We're talking about just a few inches every few months. This slow movement helps to release some of the pressure, but it also builds up more pressure on the parts of the fault that are still stuck. This means that over time, it increases the chances of a huge earthquake happening. These massive quakes called Great Subduction Zone earthquakes, can be stronger than magnitude 8.5. Megathrust earthquakes are the biggest earthquakes that happen. They can go over a magnitude of 9.0, which is insanely powerful. Just to put it in perspective, a magnitude 9.0 earthquake releases 1,000 times more energy than a 7.0 and 1,000,000 times more energy than a 5.0. These earthquakes happen when a lot of pressure builds up in a part of the fault that's locked, which means the plate can't move past each other. When that pressure gets too high, the fault finally ruptures, releasing all that built-up energy in one massive shake. The Cascadia subduction zone is super long. That's why if it were to rupture all at once, it could produce a large earthquake. Scientists have studied this region and found that about 18 miles below the surface, the fault is completely locked. The plates there aren't sliding past each other. But deeper down, the plates start to slide more smoothly, causing less friction. This is important because it tells us how much stress is building up in that locked zone, and how it could eventually lead to a major earthquake.
The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the New Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri, completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid fault, putting even more strain on the nearby Reelfoot fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earthshake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hot spots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not one, not two, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river. And depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out.
On September 16th of 2023, without warning, the Earth began to hum. A low, strange vibration reverberated through the crust. This set off seismic alarms all across the globe. For 9 days straight, the planet was pulsing with this horrifying rhythm, and scientists had no idea what was going on. Meanwhile, the total disaster was happening in Greenland. It wasn't an earthquake. They knew that much. They could tell it by the rhythm. Since we all live on giant tectonic plates, they constantly move and slide on magma like icebergs on water. Sometimes, as they move, they can rub against each other or collide or break. In any case, all this causes an incredible release of energy that sends shock waves through the ground. That's when we feel the ground literally shaking, and it's what we call an earthquake. These vibrations we feel are called seismic waves. Seismometers pick them up as pings or rumbles. In a typical earthquake, they create a bunch of different frequencies. It's a crazy chaotic mix of low and high frequencies, like smashing every piano key. What was weird about the Greenland event is that the signals weren't like that at all. It was a steady, single-frequency vibration, as if some ancient machine was stirring beneath the Earth. It's like one piano key being struck over and over, creating a doom-like, repetitive sound. Turns out, what they were hearing wasn't the noise of tectonic plates going wild. It was a phenomenon seismologists had never seen before. The days passed, and the mysterious noise just kept going. The vibrations repeated every 90 seconds, echoing around the world. The hunt for answers was growing more desperate. Seismologists had no idea what they were dealing with. They had to gather a huge international team of 68 people from 15 countries. All these scientists were gathering seismic data, satellite images, and doing some advanced math for several days, until they finally realized who the culprit was. Water. It all happened in a remote, desolate region of East Greenland. This place is full of fjords, narrow inlets of the sea between high cliffs, kinda like deep water-filled valleys surrounded by towering rocky sides. In this area, surrounded by jagged peaks and icy waters, the air was still. The landscape seemingly frozen in time. Nothing here changed much for years. Until one day. A colossal landslide has unfolded in the Dixon Fjord. One of those steep mountainsides towering over the fjord at almost 4,000 feet high collapsed in a massive landslide. Picture a huge chunk of this mountain crumbling and crashing down into the fjord below. This sent a deluge of rock and ice crashing into the water. The impact was just apocalyptic, 882 million cubic feet of debris. That's enough ice and rock to fill 10,000 Olympic-sized swimming pools, or 10 Great Pyramids of Giza. And all this nightmare hurled into the water with such force that it kick-started a tsunami about 360 feet high, taller than the Statue of Liberty, into the air. What's crazy is that this incredibly powerful wave was trapped in the fjord by narrow cliffs, unable to escape. It's like water sloshing in a closed bathtub. For 9 days, the mega tsunami continued to churn through it. That's why we heard this endless hum. It was a rhythmic back and forth of the water slamming against the walls. The shock waves were rippling deep into Earth's crust, vibrations so strong that they were picked up by seismometers around the globe. This was a phenomenon so rare, so unprecedented, that it left scientists stunned. It turned out to be a perfect storm of elements. A glacier, weakened by years of warming, could no longer bear the weight of the mountain above. This collapse was inevitable, and the chaos literally shook the Earth to its core. And people often hang out in this area with cruise ships passing by. We're lucky that no lives were lost in the disaster. It was a close call though. A tourist ship stranded in the area just 2 days before narrowly escaped the tsunami's reach by pure luck. But it doesn't mean there were no losses. The waves destroyed a nearby Inuit site, which was there untouched for over 200 years. They also swept away the huts at a research station that were about 43 miles away. The vibrations traveled from Greenland to the South Pole in less than an hour. That just shows how dangerous events like this can be. And this isn't the only place where such catastrophes are happening. In the beautiful California community of Rancho Palos Verdes, the ground is shifting so quickly that it's tearing homes apart. The land there has always been kinda unstable. It has some unique geology. It's built on soft, clay-rich soil and sits on a geological fault line, which makes it prone to landslides. This means that this land is prone to slow, natural shifting over many years, even when no crazy weather is happening. It's been like this for decades, but usually it's slow and pretty manageable, like about a foot a year. Imagine a tree that you played with as a kid moving 20 feet to the left as you grow up. For decades, residents adapted. They built their homes on adjustable beams. This helped the houses to move with the land, and that strategy worked well until now. Recently, things have been getting much worse in the community. Now, the land is moving by a foot in a single week. That would be like if the same tree moved almost 960 feet since you were a child. The past 2 years have also caused some heavy rains, and the weather has been getting worse. This increased water content in the soil. The land became heavier and more prone to rapid movement. Now, this once idyllic seaside escape turned into a disaster zone. Cracks have appeared in closets, gardens, and roads, growing larger with each passing day. Streets that were once smooth are now buckled and twisted, with roads turning into a crazy theme park. Houses that once stood firm are being ripped from their foundations, some of them split in half. One of the houses had its front door 8 feet off the ground. Entire neighborhoods have been plunged into chaos. Utility companies had to switch off gas and electricity indefinitely to prevent potential disasters. The hardest hit is the coastal neighborhood of Portuguese Bend, where residents are living on the edge, literally. It always had amazing ocean views and cool sea breezes, with horses and peacocks still wandering the tree-lined streets. But now, it's like an earthquake hit. Only this time, the earth isn't stopping. For many, this place feels like paradise, if only the land would stop shifting beneath their feet. So the locals don't give up. Some of them had to leave, but many are determined to stay and fight, despite the destruction. But they still have to pour in hundreds of thousands of dollars to save their properties. People have installed generators to keep the lights on and set up sewer systems and pumps to drain the groundwater causing the landslides. Some say that the only way for these neighborhoods to survive might be to go completely off-grid, installing power walls to store energy and stuff like that. People are trying their best to run the sewer system off generators. They hope that they could get rid of this water in the soil that's causing these hellish landslides in the first place. They're determined to fight, but they will need help and support from the government to fight this disaster. Landslides are actually more common across the US than many might think. And new maps and data show that tons of people in the country might be in danger. Scientists managed to create the first very detailed, very cool map that shows where these landslides might happen, county by county. It's based on a lot of data and the history of 1 million previous landslides. They say that nearly 40% of the United States is at risk of experiencing landslide activity, which could lead to some insane catastrophes in certain areas. Luckily, now both residents and engineers can keep this in mind. But all this shows how vulnerable we are to natural disasters, and how we should always stay alerted.
If you walk through this small stone doorway in Hierapolis, Turkey, you might never come back alive. Back in ancient times, people thought it was some sort of portal to the underworld. Romans would go in carrying perfectly healthy bulls, but after a few minutes, they would watch these animals collapse as if hit by some mysterious force. But what's even weirder is that nothing happened to people. They could walk in and out just fine. Now, recent studies might have an answer for these eerie happenings, and it all has to do with people's heights. The gate, known as plutonium, named after Pluto, the deity of the underworld, is a stone doorway leading to a small 32-square-foot cave. But the real danger is what is going on beneath it. Hierapolis is a super active geological area, and there's a big crack under the city that constantly emits volcanic carbon dioxide, which comes up as a visible mist. During the day, the sun dissipates the gas. At night, the gas forms some kind of a carbon dioxide lake on the sheltered arena floor. At dawn, you need to get out of there before it's too late. This whole place can turn particularly life-threatening right before the sun rises, when the carbon dioxide concentration, about 15 inches above the arena floor, reaches 35%. That means birds, bulls, and even humans can suffocate and pass away in just a couple of minutes. But there is a scientific reason that explains how Romans could get out of there unharmed. The carbon dioxide concentration drops quickly with height. So animals perished while their handlers, being taller and standing up, could walk out and breathe safely. Most people can't stay inside the Begarn fort after sunset. This 16th century fort, located about 146 miles from Delhi, is known as one of the most haunted places in India. During the day, the area is bustling with visitors who can walk through the main gate of this once grand fort city and check out the ruins of temples and palaces. But they will also see this big sign at the gate that dramatically warns everybody that all access is strictly forbidden after dark. That's probably because at night, according to locals, women can be heard screaming and crying in that place, along with the sounds of bangles breaking and strange music. Others have reported seeing shadowy figures and flashing lights among the ruins, or even smelling a strange perfume floating around. Yawata no Yabushirasu is one of Japan's most restricted forests, located in Ichikawa. The forest itself is a small area, covering just a little more than 40 square yards, and it is mostly a thick patch of mosu bamboo. Its location next to a parking lot and modern buildings makes it seem less intimidating, but don't be mistaken by its appearance. Since at least the 19th century, people have said that anyone who enters this forest is bound to disappear and never be seen again. So, as soon as you arrive, a sign near the forest tells you about its history and the curse believed to be linked to it. Some rumors suggest the creepy presence of an ancient samurai lord walking around. Other legends say that the forest hides a bottomless pit filled with poisonous gas. Whether these stories are true or not, today, the area is enclosed by stone walls, and entry is still strictly prohibited. In a valley called the Dark Entry Forest in Connecticut, you will find Dudleytown, but you definitely shouldn't go inside. Not only has the land been private property since the 1920s, but it is also known as one of the spookiest places on Earth. This place was first settled in the early 1740s, and many of the original settlers were from the Dudley family. That's why it's called Dudleytown. There's a local rumor that the town's founders were descended from Edmund Dudley, an English nobleman who lost his life for treason. The legend says this curse followed the Dudley family all the way across the Atlantic to America, and their misfortune is said to be responsible for crop failures, mental problems, and several tragic incidents in the village. Again, it is all just rumors, since historians haven't found any real evidence to support these claims. Still, the pitch-black surroundings and the eerie Blair Witch Project vibe going on in that place fueled ghost stories in the 1980s. This led to many cases of vandalism in the following decade, and because of that, the landowners closed the area to the public. This old abandoned building used to be the fancy palace of King Farouk's family, who was the penultimate king of Egypt back in 1936. After his family members passed away, the palace was turned into a morgue. Locals say that today, the whole place is super creepy and off-limits. Some people have reported seeing light bulbs flicker and shadows move around, making strange noises. Once, a group of kids allegedly went inside and totally freaked out when they found all the doors had suddenly disappeared, leaving them in complete darkness. They had no choice but to start screaming for help. This Hawaiian island has been off-limits to people for over a century. It's called Ni'iau and is the smallest inhabited island in Hawaii, covering around 69.5 square miles. It has around 84 residents. The island doesn't have cell phone service, paved roads, or power lines, just solar panels for electricity. A single family has privately owned the island since 1864, when a Scottish farmer bought it for $10,000, which would be around $250,000 today. The island has stayed in the family, passing down to its descendants, the Robinsons. They have kept it private ever since, so access is highly restricted and basically by invitation only. The Erdstall tunnels are a network of about 2,000 mysterious underground passageways mainly found in Central Europe, especially in Austria and Bavaria. These tunnels are usually narrow and cramped, often just wide enough for one person to squeeze through at a time, and they are believed to date back to the Middle Ages, as far back as the 12th century. What's really puzzling about these tunnels is their purpose. Despite a lot of research, nobody really knows why they were built. There is a theory that they were used for storage, but since many of them are below the waterline and occasionally get filled with water, that doesn't seem very practical. These tunnels have very light, almost claustrophobic sections and sudden drops, which doesn't seem practical for other straightforward uses like escape routes, hiding places, or even spiritual purposes. To make things even more mysterious, there is a complete lack of artifacts, which makes it even harder for researchers to figure out what these tunnels were really for. Since 2019, adventurous people can get arrested if they try to climb this rock. Uluru, also known as Ayers Rock, has been off-limits because it is now considered a sacred site for local communities. But the fact that it is also extremely dangerous probably played a big role in the decision to close it off to visitors. This rock is 1,142 feet high, which is about the height of an 80-story building. The climb to the summit can be very slippery, and high temperatures, which can hit 116 degrees Fahrenheit in the summer, have led to people passing away from dehydration and heat-related issues. Something even creepier happens at the top of the rock right after storms. When it rains, small tadpole-like crustaceans called shield shrimp hatch in temporary waterholes and rock pools on top of Uluru. These extraterrestrial-looking creatures are about 3 inches long, and they spread their super-resilient eggs everywhere. When enough summer rain comes, they hatch and go wild, feeding on microorganisms and bacteria in the water. How these strange creatures end up in the fleeting pools on top of Uluru is still unclear, but the most likely explanation is that their eggs might travel there with the wind.